last week with Glav, you ran through AngularJS, in my understanding. I saw a little bit of that. What I was going to do is we'll run through the same basics again in terms of what is Angular, how do we plug into it. We'll run through that reasonably quickly. I understand you haven't used much of that yet, so we'll just revisit that. Ultimately, what I'm going to get to in this section, though, is we'll look at some other concepts of how do we mock data and services and things like that so that we can actually write JavaScript unit tests against our Angular controllers and things like that. So we'll get into there'll be some reasonably complex concepts in here, I guess. Not so much because the concepts themselves are complex, but we're plugging a number of different ones together to make stuff work. My goal out of this is not necessarily that you can just pick this up and write this, but it's that you know what's possible in terms of an engineering approach down the track. So you've got something to work towards and know what the building blocks are. All right? So the first thing, anywhere I'm going and building stuff from the front end, I like to do a front end back style approach. So start from the front end and build back to the back end. As in, rather than thinking about, oh, what's on our API, how do I bring this down to the page? Start from what do I want on the page, and then we'll build back and we'll find that data in those services along the way. Otherwise, so that's a good approach for just keeping say the communication over the wire nice and small and efficient, just what you need, and having that really good link between the front end and the back end. If you start from the back end, it often will be sort of, oh, we've got this database table. Okay, I need that in an object. Select star. Okay, that's now this object with like 1 million properties on it. Okay, cool. I'll expose that over an API. Now I'll work with that from the client. It's like, well, we don't need 80% of that data. Those 5 properties there are a security concern. Like, this is now totally intertangled. Let's not do that. Generally also try not to make any assumptions about the data. Start from the user experience. Now, I mean, there's a balancing effect there of you want to be thinking about user experience should be thinking about your business problem, but starting from the user experience and then working back, and then as you're developing your application, instead of going, okay, we need to store a list of team names, let's start with the database. Instead, I like to go, okay, we want this interface for manipulating teams, let's start with the UI, and then we work back to build enough of the back end to support that. Yagni is one of my favorite terms. Yagni, you ain't going to need it. So anytime you get people going, oh, we can do this reusable UI framework for this. And it's like, well, you're only building one page. Yagni. Wait until you actually need it. So only build what you need. And then also focus on these kind of thin vertical slices. So where we start from that front end, going back to the back end, particularly as we're doing UI work, initially things will seem to have perhaps a lot of similarity, right? So we'll say, okay, we've got our team management page where we want a list of teams and we want to show who are the members of all those teams or something, right? And then, so we have this kind of get team API. And then we go and build a drop-down somewhere else where somebody wants to, you want to change what team somebody's in. So you use the same get teams API. But then back on the team management page, all of a sudden you want to show permission data, so you load that in. So now just for this little drop-down, you're downloading a list of all the teams, all the members, and all the permissions and stuff like that, right? So particularly with UI, I like to keep very distinct, thin vertical slices of what does this page need, what does it need from an API, what does it call from a back-end service. Because even if it looks exactly the same as something you're using somewhere else, more often than not, it's probably going to go and diverge off and evolve in a different way, right? And the UI starts to get particularly, it's a place where you can get very intertangled because you're using multiple different languages. You've got, say, JavaScript, which is bound onto some HTML, and the HTML lines up with the CSS, and then it's doing a REST call over HTTP back to something else. It's hard to refactor. It's harder to refactor than something like C#. C#, we've just got a bunch of C#, and as long as it compiles out the back end, we know it works, right? And we can use tools to really go and help us with that. It's a lot easier to untangle ourselves there. The front end, you always want to keep it a lot nicer and cleaner and strictly sliced. So it's kind of a bunch of principles that I stick to. Basics of page request. So we discussed a little bit of this in the JavaScript talk, but just a useful building block to make sure we're all clear on. Simple stuff that we need to build up on from a web perspective. We type in a URL, the browser goes out, does an HTTP GET request. We get our content, comes back, we start parsing down, parses the head section, we see a style sheet reference. We do another load, we come back, we see a script reference. We go and load that, we come back, we execute the JavaScript file. When JavaScript is executing, nothing else happens. We're not parsing our page, we're not executing other JavaScript. JavaScript is single-threaded. We literally grind to a halt and we do nothing while JavaScript is executing. It also, in basically every browser runs on the UI thread. So if you have a long-running JavaScript script that's in a tight loop or something, that's where you click on a page and Internet Explorer just fades out to white because it looks like it's frozen or something, right? Because it's using the UI thread. And then finally we go and display something. Now what we're going to be doing today is focusing on a single page application. So all of this stuff coming back from the server at this point is all static content. We composite it all on the browser and then we'll go and do API calls for data. That page request flow is very useful to keep a tight understanding of everything we do with web dev. And we've talked about performance and blocking your browser. Okay, so we're going to be building a SPA app. So SPA, single page application, this is stuff like Gmail, right? It comes up, we're not navigating between pages, we're just using Ajax to load more data in. So it's distinct from kind of a web page or something in that a web page is just us delivering markup down to a browser. You click something, we go all the way back to the server. We get down to the browser, server, browser. A SPA is we're actually running an application on the client, in the browser, in JavaScript, and then it's just going and loading data in, right? I think it's a worthwhile distinction to make, web page or website versus SPA, because the architecture and the engineering principles you'll use will be quite different. Now, particularly in the context of this talk, we're going to get through to doing stuff like unit testing and dependency injection and all that sort of stuff in JavaScript, which in a lot of cases, if we've been building web pages, websites, we won't bother with that sort of stuff. You don't need dependency injection to display a table on the page or something, right? We don't typically write a lot of unit tests. But as we start to push our applications further and further down to the browser, we've really got to take all those engineering principles with us. And a lot of teams aren't so good at that yet. But you will be. So what happens in a SPA app? I might try and zoom in on this diagram a little bit. It's a bit light. Oops. So the first thing we've got in a web page is this concept of a DOM. The DOM is the document object model, right? That's how it's the API that we use to talk to elements and that are rendered on the page. So markup turns into elements, like input text boxes and stuff, and the DOM is the API to access that object model. In a SPA application, we'll have some sort of view. So a view is going to be defined in our HTML templates, and that changes the DOM. So when we have, say, a list of things, or say a bunch of rows in a table, we're going to update the view, which is going to go and create elements in the DOM. The way that the view knows what to do is it's going to be observing a model. So our model is going to be a JavaScript object that stores some data in it. Models, anywhere at any layer of your application, are basically just objects with properties. In order to know how to take that data, turn it into a new bunch of stuff, and then push that into the DOM, it's going to render a template, and the model is going to query and write to some storage. So the other thing that we'll react to, and we'll get into the details of this, is that the DOM raises events. The user clicked this, they tabbed out of this. The events will react to those. Now, there's some terms coming up here in terms of view and model. There's a particular pattern that we're going to be using to do this in our coding sense, which is a thing called MVC. So we've seen ASP.NET MVC. We're going to be using the same thing in the browser. This is what Angular does. So just another diagram. We'll spend a little bit of time in slides and we'll go write code. The user, they go and do something, they click something on the page or whatever, and that basically causes some effect on the controller. Right? The controller's aware that they clicked the button. The controller is then going to manipulate the model to reflect whatever the new state is. The user's done that, what's the new state? We store that in the model. When that model's been updated, it's going to cause the view to update its rendering. Right? So the user clicked an add button. We told the controller to add something. The controller manipulated the model by adding another entry to an array. The view saw that and updated and went, oh, there's another entry in an array, so it's now going to display that on the screen, and then the user's going to see that. It's kind of a cycle of information going around. So we have the model is state, the view is rendering, the controller are actions, and the user is the wetware at the end of it. Familiar with that term, wetware? Hardware, software, wetware. You're all wetware. This is hardware. Wetware. Squishy wet stuff. So SPA apps, HTML goes and defines our content areas. We're then going to be doing everything via JavaScript and manipulating it that way. History, I think Glav spoke about history last week, but for the sake of touching on it quickly, it's a particularly important thing in SPA apps. One of the newer things we have in browsers is actually a thing called the push state API. go and load this up. Which is that in a Spire app, as we're going and navigating around, think when you go into Gmail, you click into an email item, the user might want to click the back button in their browser. But if they do that, they're going to come all the way out of your application, right? They might also want to be able to copy the address bar and send that to somebody as a link. Maybe not Gmail, but other applications. So what we want to be able to do is, as people are going and moving around our application, we actually want to be able to maintain that URL. There's a newer API in browsers, which is called pushState. And this site is just an example of those. So I can do window.history.pushState, and I can push a state object, a name for it, and like a URL. So when I click this, I might zoom in a little bit more up here. In the address bar, you'll see the address bar changed. And I can go and push multiple bits of state, but it never actually reloaded the page. So actually via JavaScript, we can change what the address bar says. Not even just with a question mark, we can even change the slashes, which is kind of cool. And then, oops, get the magnifier out of the road. Under my back button, I actually have those other states in there. So I can hit back, and I go back to that state, and we can subscribe to events. So that's the thing called the History API. Pet naming peeve. A lot of these things are referred to as HTML5 APIs, or new APIs in HTML5. It's basically just the timing thing. HTML obviously doesn't have a JavaScript API for manipulating the address bar. Doesn't make a lot of sense. The newer HTML specs do describe some JavaScript APIs for manipulating HTML and things like that. They've unified a lot of things. But really, it's just about this new wave of APIs we have. And a lot of things get wrapped up into that. So people talk about things like the HTML5 geolocation API for talking to the GPS in your device. It's nothing to do with HTML5. It's not even technically called that. It's not produced by the HTML working group. It's just the geolocation API. HTML5 basically just means new and sexy. So anyway, so the push state API is something useful to know about, but we won't really be using that today. So to go and manipulate all these things around and use our MVC pattern, AngularJS, I'm going to skip through this reasonably quickly. You've spoken about that before. The main thing is, the typical question that comes back is, oh, what about knockout or something like that? Now, what's nice about AngularJS is it's an entire MVC framework all in one. You might come across other things like knockout. Knockout is a good MVVM framework as a pattern, model, view, view model, and some of those bindings. But for example, it doesn't have templating in the box, stuff like that. So you end up wiring a number of smaller libraries together. So that's generally why these days we like AngularJS, is it's everything in one box that we can just turn on. In the real world, use whatever makes you happy. It really doesn't matter. All right, let's go, and I'm going to spin up a basic simple page, which we're going to build on as we go. So we'll do, I've created actually let's create a new one. Visual Studio. I am going to create a ASP.NET site to do this, ASP.NET web application. I'm going to choose the empty template and create that. Now the value of using an ASP.NET site, even though we're building a Spire app, is we can still use ASP.NET on the server side to help us do stuff like combine and minify JavaScript and combine our CSS files and minify them, reusable blocks of markup and includes and stuff like that. It's a useful thing. And also there'll typically be, we'll have like a web API or something that we're going to be calling back to get data, which we can host in the same application. But within that, I'm just going to add an HTML page for now, call it default. Oops. And we'll get rid of the early 2000s XML namespace. We tried XHTML and nobody liked it. All right, so I'm going to build a transactions list, H1 transactions, and we like having semantic markup, right? Semantic markup means markup that describes the content, not for the sake of layout, but what the content means. It was getting away from, particularly through the 90s, we used a table to lay out everything. Now we want to have nice semantic HTML that describes the content. We use CSS to lay it out. At one end of that spectrum, though, a lot of people sort of walked away from that going, you can't use tables. You can, if it's tabular data, right? Totally valid. So what I'm going to do here is I'm going to have a list of transactions. Transactions have a date, they have a credit, a debit, and a memo, as in like the description field. Here I'm putting this in a T head section. So this is the sort of semantic stuff. I'm saying this row is my header row. This isn't a TD for the data cell, it's a header cell. All of that stuff's important. And then for my T body, I can go and put some rows in here, and we can say on Monday there was a there was no credit, there was a $50 debit, and it was a taxi or something like that. So I'll start off whenever I'm building applications with just spinning up some basic static markup just to get my data showing up on page and starting to build out my UI. Simple enough. Now, because I've gone and used some semantic HTML there, I separated out that T head section and I used the TH instead of the TDs, automatically I've got some default styles for stuff like header styling on my table. Accessibility, users using a screen reader, as they go through here, it'll actually read out date, Monday, credit 50, credit blank, debit 50, memo taxi. It'll actually read that out as structured information, helps search engines, all sorts of stuff. Good thing to do. So we've got that, but now I want to go and have my transaction data actually get loaded in from somewhere in JavaScript, right? It's going to come in from the model. So the next thing I'm going to do is, using my package manager console, I'm going to go and get AngularJS from NuGet. So I'm just going to say install, I'll zoom this up a bit, install package AngularJS, and that's going to go off and download all the source content for us. So NuGet's great for not just our .NET dependencies, but also for actually pulling in a number of static dependencies as well. It's also excellent for testing the performance of SSW's internet connection, / anywhere you present. It's always like, please work. So that's going and pulling in all sorts of stuff. Now, common thing that this package does though, which is not very nice, is it's just going and dumping everything straight into the root of our scripts folder. And what it's doing here is actually downloading a whole bunch of localization scripts as well. That finished? Oops. Still hasn't finished. There we go, done. I don't really like the AngularJS package, how they go and do this. They've added all this crap into my scripts folder. So what I'm going to do is move that into an actual Angular folder, so we can keep that as a bit of a self-standing library. Just going to drag all that in there. Visual Studio doesn't like manipulating large chunks in Solution Explorer at once. And we're done. Cool. And let's go load the Angular framework in. So I could jump in here and I could type script source equals, and I could do that. Or under Solution Explorer, if I find AngularJS, I can actually just drag and drop that in, and it will build out my relative path. Now, if I was doing this into a CS/HTML file or something, where it knew it was going to be executed through ASP.NET, it would actually do the tilde/ for the root referencing on it as well. Here I'm just in an HTML page, so that's not going to work, so we can't do that. So I've added my path into AngularJS, and I'm going to go and create a new JavaScript file now to host my application code, which is going to be, I'm just going to call this controllers.js. Actually, no, we'll call it transactions controller. Transaction list controller, let's do that. Right, what's the first thing I type in my JavaScript file? Use strict. Ah, and even autocompletes for me. Use strict. Some of these autocompletes, I won't actually be able to tell you necessarily where they're coming from. One of 3 places. Visual Studio has some good templates in it out of the box. ReSharper has lots of good templates in it as well, and lights up some really cool IntelliSense stuff. And then the third one, which I actually have installed, is there's an extension which is called Web Essentials. Web Essentials 2013. You totally want to have this installed. It's by a guy who actually works on the ASP.NET web tooling team at Microsoft. And basically he gets paid in his day job to write this. It's not an official Microsoft extension, but they play with a lot of new concepts in here for the IDE, and then in the later updates, they then bake them down into Visual Studio. But it lights up all sorts of really cool stuff. So if you have Visual Studio ReSharper and Web Essentials, you'll get what I'm getting here. Okay, so I've got my controller. The next thing I'm going to do is actually go back into my HTML, and I need to start to describe what the controller applies to and use some data binding. Now what I'm going to do in this case is on the body tag, I'm going to say ng controller. Now ng is sort of the short name for Angular. Anywhere you see that, you pronounce it Angular. So Angular controller equals transaction list controller. Now I can do this multiple blocks on my page. If I had, say, the main page was displaying my transaction list, and in the sidebar I had like a stock ticker or something, I could apply the different controllers to different, say, divs in different parts of the page. In this case, I'm just applying it to the body, so it applies to the whole page, though. So I've done that. And the other thing I need to do is actually wire up Angular as a framework. So I have to declare ng app somewhere. Now I'm going to declare that at the HTML tag, so it applies to the entire DOM. So we've got that. And now I want to go and take my transaction data, and I'll set this up so that it's ready for binding. So this row here is something that I'm going to want to have repeated out. So I'm going to say, put a new attribute on this, ng repeat, and I want to repeat each transaction in transactions. Now these don't exist yet, but transactions is going to come from my model, because we have that binding between the model to the view. Then for each thing in there, we'll put that into a variable called transaction, and we'll render another instance of this tr element for each transaction that we get. Right? And then I can just put some binding in here. So I can use this double brace syntax, date, credit, debit, and memo. Now you can see there, that's actually Web Essentials is applying special code coloring because it sees it looks like a data binding tag and it knows I'm using ng app. So it's actually that smart. It's not just saying, oh, you've got HTML. It's saying, oh, you're writing Angular and you're doing a data binding expression. Let me highlight that for you. So pretty cool little extension. So I've gone and wired that up. So now when this comes in, we've got our app. We've told it to use a controller and apply that to the body tag. But we need to go and create that controller. I'm going to go back to my transaction list controller JavaScript file. And this is, so in C# we'd create a class, right? So we can create an instance of that class for our MVC controller. How we do that is we just define a function. Now when we do that, because we haven't put that in any particular object, that's going to be available in the global window object, window.transaction_list_controller. So now you know from the last bit we were just talking about JavaScript, the way Angular is going to find this is when it looks at the HTML and it sees this ng controller attribute, sees transaction list controller. And what it's effectively going to do is it's going to go and look on the window property for transaction list controller. And it's going to get that and it's going to see, oh, that's a function. So then it's going to go and call that function to create the controller. So we've got that, but we also want to take in this concept of a scope. So the scope is the model that Angular is going to create for us. It's going to create the empty class, or sorry, the empty object, and it's going to give us a reference to that. And then let's just put some information on that. So static data again, because I'm building up from the UI, right? Oh, transactions. So I started with static markup. I had a look at that on my page. Works nicely. I might have styled it at that point. Now I want to start to get my controller working, but I'm still just going to use static data for now. I'm not going to try and talk to a service at all yet. So in here, I can go and initialize an array, and I can say date on Monday, there was a debit of $50, which was a taxi. Date Saturday, debit $100, memo, bar. Pretty sure that's what my statement looks like. Taxi, bar, hotel, plane, taxi, bar, hotel, plane. Life of a traveling consultant. And, whoops. Transaction list controller. Aha. So, my page isn't loading. The easiest way to find out what's going on, have a look at the console tab. So it's saying here, argument transaction list controller is not a function, got undefined. Haven't loaded it in. What I haven't done is gone and referenced it in the bottom of my HTML, right? So I need to reference in that controller file. Now, order isn't going to matter here for these files at this stage, because I could load the controller first. All it's going to do is define a function. It's not executing anything, and then the framework, or the framework and then the controller. It doesn't matter. What Angular does is it waits until there's a thing called the DOM ready event that fires in the page lifecycle, which is basically when the browser has parsed to the closing body tag, it fires that event, and at that time, Angular is going to go and wire everything up. So as long as you've got everything ready before the closing body tag, the Angular framework's good to go. So I refresh that, and where'd my data go? Transaction in transactions, transaction list controller, scope.transactions, date debit memo. Whoops. I need transaction dot on the front of each of these. There we go. Cool. I didn't get any errors there because it just saw it and it was data binding to a property that didn't exist, so it was undefined, so it just rendered nothing. Something I did do there, the way I wrote transaction on the front of all of them quickly, if you hold Shift and you're highlighting in Visual Studio, if I go down like that, I get the normal wrapping style. If I hold Alt, there's block select. And I can type on a whole series of lines all at once. All right, so we've got our data showing up now. Okay, let's look at that in the context of Angular, and then we'll start to load some stuff on now that we have a working page. So in Angular terms, the model is the JSON object. That's that $scope thing that we go and put some stuff on. The view is the combination of the template with the data when it gets projected. So there's some words there. This block here is a template, right? We take the model as the data. The verb that we use is we project the template. Right? So we take the template data and we sort of project that, and we end up with a view, which is an actual instance of some markup that we then load into the DOM so that the browser can then render it. So we've done that, and the controller is what's acting on the model and will respond to events from the view. Skip that. Okay, so the flow here, the JavaScript files all get loaded. We might register some dependencies. We haven't looked at that yet. That document ready event fires. Then the Angular framework goes off and it looks for ng app, it looks for ng controller, and it chases them all down. It finds what it needs to do. It goes and calls the controller, passes in the scope. Normally here we'd go off with the server, we'd get some data, we'd update that into the scope. For now we've just set static data. And then any time that Angular does anytime it sort of passes execution to the controller and comes back, it will then loop through and look for things that have changed, like placeholders in the DOM, and it'll update them. And then we repaint the page. So we've got that wired up. Before I go too much further and start adding more behavior though, I want to start to be able to write some tests against this. So we talk about TDD a little bit. A lot of people call that test-driven development. We don't really want to think of it like that. We want to think of it as test-driven design. So test-driven design is we write a test of this is the behavior that we want our application to have, and then it forces you to sort of think about how the design is going to work back from that. And we want to be able to do that in JavaScript world. So test-driven design, first of all, we start off by writing a failing test that describes the outcome we want. We write the test first. We then do enough work, just enough work to make the test green, right? No more. Once that test is green, we can then go and, so we know that our application is working as we want, we can then go and refactor that code to make it nice and clean and work better. And that whole time, we then can make sure that the test continues to be green. One of the reasons that we write the test to be red first, there's two reasons. One is that it makes sure that we design just what we need to achieve the outcome, and we don't sort of drift off down the rabbit hole of dreaming about, oh, what if I read this thing out of the database? It's like, well, no, what do you need now? But the other thing is that it tests the test. Right? If you write some behavior and then you write a test against it, you're like, hey, the test is green, that's cool. How do you know that the test is ever actually able to fail? You need to prove that the test can fail before you can trust the test. Right? Getting a green test on first go is a bad thing. This means you haven't tested the test. So I think a few of you noticed the point on here of which one's false. But it's all about shorter loops, finding problems sooner, and being able to replay all those. Working in a team environment, one of the things I like most about test-driven design or test-driven development, which is generally writing tests, it helps me work more effectively because rather than going and, there was something we were talking this morning about, you've got all your new monitors, right? So you can see your code and you can see your application. But that means you go and change the code, and then you refresh the application on the other monitor. You have to go click, click, click. Oh, it didn't work. Change the code, refresh, click, 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 every time, right? So first of all, it helps me do that faster because I can just write code, hit a key command, and it runs a whole series of tests. I can test lots of scenarios. So the first thing is I work out what are the scenarios I want to support, and then I can just focus on code. So I actually spend most of my time, like I love multiple monitors, but I spend most of my time on my laptop, and I don't miss it because I'm not actually switching backwards and forwards to the application a lot. I write most of my code, and then at the end of it, I sort of go across the application like, oh yeah, that thing still works, cool. Because I trust my tests and they represent what I'm trying to achieve. But in a team-based environment, it's also about sort of coding defensively to some extent. If you're writing your own code, you know how it's going to work and you might remember why you wrote something. But in a team-based environment, somebody else comes along, sees your code, and they're like, oh, that line there, that's pointless. I can make that, well, not even that's pointless. They might go, oh yeah, that code makes sense, but I can make that more efficient, and they'll tweak something. But they missed some particular requirement that they didn't know about, right? If you've got a test, but then what happens is, so they miss some requirement they didn't know about, and then somebody else comes along and they're like, oh, that screen you wrote's broken. Why didn't you write the screen properly? You're like, it wasn't my fault. He screwed it up, right? Whereas if you write a test, the test describes the requirement, and it makes sure that the requirement continues to exist in the code and be met. And then that way you're defensively protecting your code. You want your code to continue to live and be nice and clean and functional. But as a whole team, you want your application to continue to meet the requirements. So in your test names and things like that, it's not about saying this thing adds up these things or calls this method. We want to try to get to what business requirement does this solve. From a traceability perspective, where you've then got, say, PBIs and TFS and things like that, use the PBI names, use the numbers as the references in there. Because then when somebody goes in, they're like, oh, I can optimize this code. They change something, they go, oh, a test is failing. Then they can look at that test. They can look up the work item. They can look up the requirement or the PBI that said that this needs to do this. And then they can see that end-to-end business connectivity, right? Testing helps with that. Otherwise, you lose all this traceability and you're like, why does this application even do this anymore? And you've got no idea. I think it's much more valuable than comments. Code comments get out of sync with the code. Tests can't because they pass or they fail. So in doing that, we get into this thing called BDD. I was talking a little bit there about behavior, and we want to test business requirements. A lot of unit testing is about testing interactions and specifications. So does this object call this method or something like that? What BDD is about doing is about describing these are the behaviors that I expect from my code and describing them in that way. So there's a framework we're going to use here called Jasmine.js. So I've just installed that via NuGet. There are lots of other options available. Hyro, Casper.js, QUnit, Suite, Testacular, Javas, lots of them. For this course, we're going to use Jasmine. You can use whatever you feel comfortable with. I like Jasmine. I don't really like QUnit. I don't really care about the others. So I've gone and added that in. What I'm going to do, normally I'd go and spin this up in multiple projects. Actually, let's do that. I want to keep my test code separate from my application code, right? So in my solution, I'm going to go and add a new project. Now, to get a project grouping, all I want to do is store some JavaScript files in it. It doesn't need to actually do anything. I don't need a web application because I don't want all that ASP.NET stuff, and I don't need to run it up through a web browser, but I have to pick a project type. Class libraries are actually a really cool project type. Because if I say tests, I can delete class 1. It's going to produce a DLL on the build, but nobody cares. It has a build step, so you can actually run pre and post build events and stuff like that, but mainly it just gives me a grouping node in Solution Explorer, right? And it gives me a place in my folder structure. So a little bit counterintuitive. I want someone to put my JavaScript. Hey, I know, I'll create a C# project, but it's a cool place to put stuff. Works well. So actually what I'm going to do now is I want to install Jasmine into that project instead. So install package Jasmine.js project name tests. I'm going to uninstall it from my web application project because it shouldn't be there. All right, so that's gone and brought in scripts and some CSS for rendering Jasmine's results, because it normally runs in a browser. So then what I'll do is zoom out. I'm going to jump in here and I'm going to create another JavaScript file, which will be transaction list controller tests.js. Normally when we're writing like C# unit tests, we always add the word tests to the end of it, because otherwise the class names would conflict. In JavaScript land, it doesn't matter. So actually I can get rid of that, so we can just have one-to-one file naming mappings, right? Next line of code I'm going to write is... Yay.
With that one, you mentioned before that some older browsers will create an error with that.
No, some older browsers don't know about useStrict, so they're just going to see a string and they're just going to be like, useless string, you didn't do anything with that, ignore it, right? But in your newer browsers, it will have an effect. So we want it to be stricter to help us through development. And you'll typically be developing in new browsers, so you'll develop in Chrome or in IE11 and stuff like that. So that way, if you make a mistake, you miss var, then you'll get a nice error message straight away. It's like, hey, think you made a mistake in your code, go fix this up. Now, running that in an old browser like IE8, it's just going to be lenient and let that through. That's all. You'll just have no effect. It'll be the equivalent of if you didn't write it. Now, I'm over in my tests project up here, but I want to be able to, so first of all, I'm going to need Jasmine. So I've just dragged Jasmine.js in and dropped it on top of here. Now, this thing at the top is kind of like a funny XML / comment. What it was initially used for was supporting IntelliSense in Visual Studio. From, I think it was VS 2010 they added this. Because if we're just looking at a single JavaScript file on its own, we don't know what else has been loaded in the page before it, right? So we're not actually referencing Jasmine, but we're saying that when we use this file, whatever else is using it would have already referenced Jasmine. So that way IntelliSense knows to go and light that up. Now in VS 2013, by default it just goes and pulls in your scripts folder in entirety into your IntelliSense, and you can customize that at options with different rules and stuff, because you should have nice, tightly namespaced stuff, so it doesn't matter anyway. And in most web applications, we'd reference everything. But here we're actually going to use this to help our test runner to tell it what to include, because we're not writing any HTML here, we're just executing the JavaScript, so we do actually need to reference it. So that's the first thing. And then I also want to go and reference my controller. So I've gone and referenced transaction list controller.js. Again, just dragging and dropping in from Solution Explorer. So now what I'm going to do is I want to describe some behavior. Make this a bit bigger. There we go. So I literally say describe, and the behavior that I want to describe is my transaction screens. Right? And I pass in a callback function as an argument there. So that sort of gives me a scope. I mean, in that, I could do another level of describe if I want. I have a choice of 0 to infinity levels of descriptive sections. So now I'm describing the transaction listing screen. So I literally say it should return, it should show 2 transactions. Just because that's the data we've got so far, right? We want to make sure that there are transactions on screen. Whoa. Function. So the transaction screens, the transaction listing screen, it should show 2 transactions. So now to actually write my test. Scope, I need to have a model. Oops. I can just create an empty object to start with. We'll do this a little bit differently later. Then I need an instance of my controller. So var controller equals new transaction list controller, and that needs to take an instant, the scope needs to be passed into it. That blue squiggly there is, in this case, ReSharper complaining that based on my naming convention, I shouldn't be invoking something as a constructor with the capital, without a capital T on the front. And actually, it's also complaining about use of an implicitly declared global variable, but that's okay in this case. So then I can write an expectation. I expect scope.transactions.length to be 2. Now, what we were talking about before, I should have written this test before I went and wrote the static data, right? Test first. I expect there to be 2 transactions in my screen. But presenting, we need to go in a slightly different order, because otherwise you wouldn't know where we're getting to. So maybe if we'll make that 3 instead. So now that I've gone and written that, I need some way to go and execute these tests. Now, there's a couple of ways I can do this. I have a thing called chutzpah installed. For those of you who haven't practiced your Jewish lately, it's spelt like that, with a C on the front. You just don't pronounce the C. Actually, I think it's chutzpah, maybe. Sorry, there's no C. And what that allows me to do is I can right-click on a file and I get an option up here which is Run JS Tests, Open in Browser, and Show Code Coverage. If I go Open in Browser, this here is now, it's opened an HTML page, so it's dynamically created an HTML page. Based on those reference tags at the top, it knows what JavaScript to include. It's gone and included the Jasmine library, it's included my controllers. It's then gone and run this code. Jasmine, you can see up here it says Jasmine 1.3.1, goes and then renders this block of HTML, and it's saying one of my tests is failing. We actually got 2, but we expected it to be 3, and it's this scenario here. So it's saying transaction screens, transaction listing should show 2 transactions. So it starts to read out like some sort of business requirement, right? Now we don't normally want to go and have to constantly flick into a browser, but it's useful if we're debugging this. So the other thing is if I just right click and say Run JS Tests, in my output window at the bottom, there we go. It goes off and just runs, and it writes it out. It's just as text. It says 0 passed, 1 failed, 1 total. Just runs it. Now the way that's running it is it's using a thing called Phantom.js, which is what's called a headless browser. So Phantom.js is a browser like Chrome or IE, but we don't waste time going and actually rendering that onto a screen. We don't need to bother drawing video output on a single thread in order to be able to run a block of code that checks the length of an array, right? So Phantom.js is really nice and quick. To use chutzpah, it's another Visual Studio extension. There's this one here, which is what we just looked at, chutzpah Test Runner Context Menu Extension. So that comes from Tools Extensions in Visual Studio. There's also a second one I have here installed called the chutzpah Test Adapter. Now in Visual Studio 2013, if I Shift-Alt-Enter, we have our Test Explorer window built into Visual Studio. And via the extensions, you can install different adapters. So you might be using NUnit or XUnit to write your C# tests. And here we're using Jasmine to go and write our JavaScript tests. All of those adapters plug in. So if I then go run all in my Test Explorer window, it goes and builds my solution. And then it goes and looks through all of those to find all of the tests. And then here in my failed tests, we can see that JavaScript test that I wrote showing up there. If I went and wrote an NUnit or an XUnit test, it would show up in the same list. So then when I say run all tests, it's going to test my client-side logic and my server-side logic all in one test run. That's pretty cool.
It's treating JavaScript like real code.
Yeah, JavaScript is almost real code. We've only had it for 15 years. There's also a button here which is run tests after build. So what that can do is every time you hit Control-Shift-B, you compile your solution, it'll automatically go and run the tests every time you're doing it. So this whole 2-screen thing, if I can change my code, then I can go look at my application, I can hit refresh, I can go click, 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 oh, it didn't work. That goes away. Control-Shift-B, test everything, done. Milliseconds. There you go. That test took 11 milliseconds to run. You can't click through your screen that fast. You probably can't even load the page that fast. So that's a test starting up. The other thing that chutzpah ships is there's a console exe version. So building into build processes and stuff like that, you can just point a console exe at a folder. Or in TFS land, this is getting reasonably specific, but those adapters that we're using in Visual Studio, you can use those same adapters in your TFS builds. So then every time you push code in, TFS on the build server will use all the same adapters and light up all the same tests for you. So that anything you see in the Test Explorer window will run in your CI process and get reported out nicely in TFS. Right, so red-green refactor. If we go across to our controller, let's add another entry. Friday. I was no doubt booking another flight somewhere. So if we add that in, I can say run JS tests, and now I have one passing test. The other thing that's actually showing up here, these little black boxes, these are resharpers showing up, Jasmine suites and the individual tests. I can actually click on here and go and run a specific test if I want as well, and resharper will go and invoke that. I don't use that runner as much because they do actually go and it always fires up Internet Explorer in order to report the result out. So I don't usually bother with that. Pretty cool. All right, so the next thing we want to do is I want to be able to actually, my controller is going to need to start to call out to a real service and download some data. But I want to be able to test certain behavior in my controller. So think about, let's say every time, and I'm not going to code this up, but imagine every time we downloaded our list of transactions, we wanted to show, you know, like a total sum of those transactions on the screen or something, right? And there's different rules. We need to make sure that because we have these debit and credit as two different columns, I need to make sure I go and times the debits by -1 when I add them to the sum and stuff like that. There's logic there that we would want to unit test. But if I went and updated my controller here to go and just suddenly start calling out to a real web service, I can't test that very easily. That becomes an integration test because then I need a web service, and I need a database, and I can't create all these fake data scenarios. So we want to be able to go and mock different layers of our applications. We want to be able to test the controller, but passing in a mock like data client, right? It's dependencies. So I think you've been doing this in some of your C# already. But we get into dependency injection. We're going to do the same thing because we're building a single page application. We're not just building a little website. We're going to use the same technique here. So dependency injection is something that allows us to inject objects into classes instead of those classes creating the objects themselves. Decouples them. Angular makes very heavy use of it. So just to recap, in C#, if we had, say, class A creates class B, so we go new class A and in it, so we say new transaction list controller, then it goes new web service client. What we do instead is we say the application wants a class A, it creates a class B first, so like the web service client, and then it passes that into the controller. So then we could pass in different implementations of that. Inversion of control is about classes declaring their own dependencies. So it just requests what it wants and the application services them. So this builds on top of dependency injection. So inversion control different from dependency injection. So application requests a class A. We use a thing called a container to do this. So some framework thing. And we say, hey, we want a class A. The container goes and creates class B, passes that to class A, and then returns that back to the application. So it's also nice in that we can have these nice single responsibility little classes sitting around the place, but we don't have to go and create them manually. Because otherwise you get these constructors where you're like, okay, I want to create a transaction list controller. Oh, it needs a data client, so I'm going to create a data client. Oh, it needs an HTTP client. Oh, okay, I'll create one of them. Oh, that needs a service point manager so we don't overload the server, so I'll create one of them. And all of a sudden you get these massive dependency chains of stuff, which is good because you've got lots of single responsibility, but if you're not using a container, it sucks to go and create them all. So we want to get away from that. So dependency injection in Angular. So jumping back into the Angular view of the world now. What it's doing for us so far is we're already seeing a little bit of this. So in our default HTM, we didn't go and pass in, here's the instance of the controller. We said, this thing uses a transaction list controller. It went and looked at transaction list controller, and it sees, oh, that needs a scope. So it creates a scope for it, and it passes it in. Now what we want to do is actually have a transaction, say, service that comes in. Transactions service. This is going to be the thing that goes and downloads that data for us. So I declare that as a dependency for my controller to work. It's the first thing I need to do. Let's go and define that service somewhere. So if I jump in down in my scripts, I'm going to create a new JavaScript file, transactions service. Now, I don't want to keep just going and loading random constructor functions onto my global window object, right? Hopefully we're beating this principle in. Don't want to corrupt the window object. So I want to modularize them, some sort of library. So what I'm going to do is go angular.module, and I'm going to define a module called, say, data services or something, kind of like a library of some form. I have to supply an empty array here Now, that array would normally describe, and we'll get to this, but that describes other modules that I depend on. Now, remembering that we don't have overloads in JavaScript functions, even though that's just an empty array, if I don't supply that, Angular is going to see, oh, only one argument, and it will retrieve that module for you. To create the module, you have to use 2 arguments, even if you have no dependencies. Off that module, we then have this fluent interface. So I could go and say, like, var module equals, so we've defined an empty module and now put stuff on the module. But with our fluent interface, I can just put another dot and I can just keep calling stuff. What I'm going to do on it is I'm going to define a factory. So this module defines a factory. Just like in the real world, factories build things. So the transaction service, we have a callback function. So this is saying I'm providing a module, which is a library, and I have a way to build a transaction service. Whenever you want a transaction service, just come over to the factory, ask me for one, and I'll build it for you. And the way the framework comes over and asks for it is it invokes this callback function. So here our responsibility is to go and build one of those. It's just an object, so I'm just going to return an object. Oops, indenting having fun. And on that, let's just return some static data. So that might actually have a function normally to go and query or something like that, but we'll just declare some static data. And rather than retyping it, I'm just going to copy that static data that we were using before. And we can shift I'll make all the debits 10 times as large so that we can see that the data's changed. Every time I shuffle the data around, I tweak it a little bit so I can make sure my application's actually querying the new spot. Right? So now, in my controller, I would actually say transactions service.data. I just go and use that. So the controller's job is, how do I retrieve, I need to go and get this data. It doesn't know how to ask for it over the wire, but it just gets the data, and then it does whatever it needs to do to put that in the right place in the model that the view could use it. All right? So I could also say I want to display scope.transaction count. Let's var data equals that data.length. I mean, that's a really simple example, but I'm taking that data in and I'm reprocessing it in some way that I need to do for the UI, right? Now it's not quite going to work yet. So we've defined this new services.js. We're going to need to reference that in our page, right? So I'm going to jump into default HTML, add that additional reference we need. And again, order, in this case, is not going to matter because none of this code's actually executing, well, the JavaScript files are getting executed at the point that I reference them, but all we're doing is just defining functions and stuff. We're not actually going and running all that code yet until Angular hits document ready. If I go over and reload my page, I'm going to get an error. This is by design, but we'll look at what that error is. So my data binding is not working. I go and look up here. And this error is terrible. It's reasonably convoluted. But it's useful. It's easy enough to understand once you know what pieces to pick out. So it's saying unknown provider, transaction service provider, transaction service. What on earth is a transaction service provider? What it's saying, what it's trying to say, but saying really badly, is, hey, I went looking for a thing called a transaction service, and I couldn't find one. So I then went looking for a transaction service provider, and I couldn't find one of those. So it's kind of like it's showing the second error. It's the first one that we really care about, is that it couldn't find it. Now, even though we've gone and referenced in our HTML, we've pulled in that extra service.js, we defined it in a module, right? We defined this data services module. So we now actually have to tell Angular to load this kind of module in. So sort of like adding a reference in Visual Studio into a C# project, right? So the way we do that, I'm going to create one more file. Feels like we're creating lots of files here, but these are kind of the boilerplate things that you'd set up once for your project. And I'm going to call this app.js. The first line I'm going to write is useStrict. Now what I'm going to do in this app is I'm actually going to define a new module, angular.module, transaction app, or I call it banking app or something. It's just a module for our app. And I'm going to declare a dependency, data services. And I'm not actually going to put anything in that module itself. I'm just defining a module for our application and saying what our dependencies are of these other modules. Oops. Angular. So that's called banking app. Last thing I need to do to make that wire up, back in my default HTML, is I am going to have to add a reference to app.js. But up the top where we do this ng app on our HTML, I'm going to name it. So I say ng app equals banking app. So that kind of says the module that we're working with here is that one, and then it will go and load the dependent modules and they'll become available. So I'm not going to do it now, but the other thing you could imagine is this controller we went and wrote that's currently sitting on our global window object, we could actually pull that into the banking app module so that it was sitting there in a nice modularized way on the module if we want it. All right? Okay, so let's make sure this runs. Doesn't. Transactions service. Transactions service. I didn't save default HTML. There we go, cool. So our new data's showing up. All right, so before I go back to the test, let's just run through what we did there. So Angular, when it loads, well, when our browser's loading, it's going to read through this HTML, sees, yeah, HTML, great, whatever, and then it gets here to the scripts. It goes and loads the Angular framework. Nothing happens yet. In the background, Angular has subscribed to the DOM ready event. We spin up app.js, which is defining a module called banking app and some dependencies. Nothing's actually really happened yet. We define our transaction list controller. We're just shoving that in the global window object. We'd be better to have that on our module. We're loading our data services module that has a factory on it. Then we get to the closing body tag. The browser fires the DOM ready event. Angular starts to spin through the HTML. It sees ng app. It goes and loads the banking app module. It then looks for any ng controller tags on the page, which there could be multiple. It goes, I need a transaction list controller. Now it's going to search through the modules it knows about first, but otherwise it falls through the global window object. That controller, when that gets instantiated, it's going to get given a scope, and it's requesting some data services. It's going to go and query the data from the data services. It's going to store that in the model. Angular is going to see that we've manipulated the model. It's then going to go and run our view. It's going to project the data into the template to produce the view and load that into the DOM. And finally, we have some stuff shows up on the screen. Sounds like a lot of steps, but we've got some pretty nice separation between different parts of our application there, right? Now, what this means as well is that if I go back to my test, which I've now broken, it's not going to work. Yep, test failed. Because if I go run JS tests, we're going to get undefined is not an object, evaluating transaction service.data. Because in my test, I'm just saying new transaction list controller. I'm not supplying that second parameter. Parameters you don't supply are undefined. In the controller, we're then doing undefined.data, right? So what I could do here is I could say, should show transaction count is really what we're aiming for. We want to show our transaction count on screen. So if we pass in some known data, if we pass in 3 rows, we expect it to come up with 3 in the model, right? So what I could do here is I could say transactions service, but we could just go and mock this. We just define it. It's totally fake. Transaction service is an object. Data is an array of, oops. Three things. And we expect our transaction count to be 3. Let's make that 4. All right? 1 passed. So what we're testing here is we're testing the real controller, but we're passing in a fake data service with whatever data scenario we want. So we don't need to call out to a real API. We don't need to mock data in the database or something like that. We can describe the really specific scenarios we want to test how that controller is going to go and react to that data using that dependency injection, right? Some interesting things that can happen here, though. we like to minify our JavaScript. So default.htm, we're currently referencing 4 different JavaScript files. They've got new lines and space all through them. It's really inefficient from a browser. We spend lots of time going backwards and forwards over the wire, lots of latency. Do that on a 4G device and you're just clocking up seconds of latency, right? We don't want to do that. So normally we'll compress JavaScript down to a single file called bundling, and then we'll minify it, which not only takes the space out, but also takes out things that shouldn't matter. So what a minifier is going to do when it sees this code is it looks at scope, and that there's only valid in the context of this function. Nobody cares about that. So it's going to turn that into A. And it's going to see transaction service, and it's going to turn that into B. And it's going to see this data property, and it'll turn that into something like C. And then it will go and strip out all the new lines and blank space. Now that's made our code shorter, less to transfer over the wire. But then when Angular goes and looks at this, it's like, what the heck is an A and a B? How do I make one of those things? It's got no idea, right? So you go and write your nice Angular code, you go and put it through your bundler, which is in your default MVC template, and your application will just fall over. It won't work. We can fix that though. Functions are objects, remember? So if I go transaction list controller, I can put a property on that, which is a hint to Angular. And I can put an array of strings there which says, when you're doing your injection, the things that I want you to inject are these things. So it's not going to look at the argument or the parameter names here, A and B. It's going to go and pull them out of this array instead. So simple little convention alongside that gives it the hints that it needs to know to work. Anywhere you see dollar in Angular, that means it's kind of an Angular concept. If you see $, it's an Angular concept, but it's private, it's internal. They reserve the right to change that API at any time, and you probably shouldn't be using it. Dollar is good, $, bad. It's just an Angular convention they use. There's nothing special about dollar in JavaScript. It's just a valid identifier. So it's nice for signifying like frameworky type stuff, because you wouldn't use that in application code. So anyway, so that there, if I go and reload that, my page still works, even though my dependency injection's all stuffed up in the parameter names. Okay, is everyone happy with that? Cool. So, do my tests actually work? Yeah, it does. One test passing. Cool. Some of the other things that I can do, I won't go and test that. There's another, I guess getting back into JavaScript land, there's some other tools which are quite useful just in a JavaScript sense. There's one called JSLint, where we can go and take our JavaScript and run it through, and it'll look for common mistakes and things that are likely to fail in your JavaScript. It's kind of like a compiler / checker. It's fairly opinionated, perhaps a little bit too much to be actually practical. So there's a fork of that, or the same sort of concept called JSHint, which is a friendlier, more pragmatic version of verifying your JavaScript. That's quite a nice tool to have, and there are Visual Studio extensions, which I don't have enabled currently, where you can get it so you can just right-click on something and say, lint this or JSHint it and things like that. So that's fun. That'll go and pick up unused code, places where you're not using triple equals but should, stuff like that. All right, where are we at for time? It's about 45 minutes. Working out whether we should talk about HTTP or not. Okay, cool. All right, should we talk through a little bit of REST and pull some stuff down? Cool. All right, so let's go pull some real data down. So REST as a concept. So we like running web services over HTTP, right? HTTP API, something we expose over HTTP as a protocol. URIs, important thing to note, Uniform Resource Identifier is what they stand for. That becomes important. HTTP is nice because responses can be in any format we desire. We can send back XML, we can send back JSON, we can send back CSV, all sorts of stuff. It's a great format for that. HTTP is just a transport protocol. It's not actually a, like an application sort of protocol. It means that we can do really easy stuff like, oh, we want to encrypt it. Well, we just turn on SSL. Right? Oh, we want to do authentication. We can just turn on authentication. Oh, we want to cache it. We can put caching layers in front of it. There's lots of stuff we can do at the infrastructure layer with HTTP APIs that are quite nice. And everything in the world can talk HTTP. Literally everything in the world can talk HTTP. This is when it loads. That's my bathroom scales talking HTTP. That's literally my weight and body fat percentage that gets uploaded over Wi-Fi from my bathroom scales. Everything can talk HTTP. It's great. It's also how I know my Wi-Fi is down, as my bathroom scales tell me first. It's a little bit sad. All my other devices just fail over to 4G. Then you get on the scales and you're like, oh, they're complaining, there's an error. I should probably go check my internet. There's another format called SOAP, which kind of got popular and we're now trying to kill off. SOAP, Simple Object Access Protocol, is kind of a joke. It's very verbose. This is what happens when we've gone and created old ASMX services in the past, ASMX services in earlier versions of .NET and stuff like that. It's not .NET specific though. It's very fixed format. It's lots of XML. It's kind of remote procedure calls. They have all these other things they had to go and add on top of it, which are called WS star, all these other different specifications for security and all sorts of stuff. You need custom tooling to use it, in that if you just want to go and call an API that somebody exposes over SOAP, you can't really practically do that. You've got to go and download a WSDL file and then run a tool against that that's going to generate some client code and keep all that in sync, and we've kind of got over SOAP. Instead, where everything's going these days is into REST. So REST is representational state transfer, which is what HTTP is designed really well to do. So we start talking about things called resources and methods. We can negotiate formats, so we'll have a look at that. So let's have a look at that now. When we go to, if I bring up my F12 tools, I look at the network tab, and I type in google.com. If we have a look at the headers that go up, in the request headers, okay, we'll do that. One of the things that it's sending up is this accept header. It's saying accept text/HTML, application XHTML plus XML, application XML, Q equals 0.9, image WebP star Q equals 0.8. Now what that's saying is the browser is saying, I would like this particular resource. It says get / the root resource of the domain. And I'd like that in one of these formats, please. And this is a prioritized list. So kind of a 0.9, I'm going to just stop scrolling now. There we go. Like it would prefer one of these three things most. It'll take some WebP or anything else as 0.8, lower priority, right? So it can go and ask for that. So we can have one API that will return different formats. Now, JSON, JavaScript Object Notation, is great in the browser. It works really well with JavaScript and transferring stuff backwards and forwards, much better than XML parsing. In a lot of other applications, certain frameworks might work better with XML, things like that. So the API doesn't have to care. We're just trying to transfer state in different encoding formats. We've got both the data and metadata that goes back with it, in the sense of we always have HTTP headers on the response. Is a great place to put metadata. Stateless, because statefulness is expensive and painful in web environments. When you scale out to server farms and things like that, state will always bite you. Session state, pretty much always a bad plan. Sticky load balancers, bad plan. The web is stateless, so REST is stateless. But we don't need tooling to do it. We can just access this stuff in a browser really easily. This is why we like it for a web environment. So how do we go from a traditional SOAP API that we might understand to REST? If we imagine we had something like this, we've got get all customers as a method, returns an array of customers. We might define that in C#. All these specific little things. These describe all these different actions that we can undertake on our API. Over the wire, all of this is a call to one address, like customers.svc, So one URI, and it's always via an HTTP post verb. So at the HTTP infrastructure level, we don't know what's going on. We actually have to parse out the XML to see what's happening. In a REST API, we use different HTTP verbs to talk to different resources. So if we get customers, that's going to return us a list of all the customers. If we get customers /3, it's going to return us customer 3, stuff like that. We can then use those accept headers to negotiate the content formats. We can say we want this as JSON, or we want this as XML, or different things like that. The other verbs we've got, post is going to go and create something. So if I have a customer object and I post it to /customers, it'll create the customer. Put is going to go and update content, delete will delete it. There's a few other verbs as well, but having these HTTP verbs gives us a well-known set of interactions. I know that get is not going to affect state. It's not allowed to affect state by the definition. If you have a get API that affects state, it's broken. So I know that I can replay that get as many times as I want without any effect. But I know that every time I post, I'm going to create a new customer. So these semantics become well known not just to us as a developer, but to any other APIs along the way, right? So for example, a browser knows that you can replay a get. When you hit F5 and you do reload, it reloads the page. If you've taken a user from one page to another via a post and you hit F5, you get that dialog that comes up going, warning, form resubmission, because it's a post. It knows that this is manipulating state on the web server. When you see those types of dialogs, that's what it's doing, right? Really useful for us to know that sort of stuff. There's two different ends of it. So we talk about this then maturity model of REST services, or as a maturity model. Level 0 is SOAP. It's the swamp of POCs, plain old XML. It's just piles of XML. Then we start to use different resources. So those are different URIs, so having addressable URIs for things. Then we start to use HTTP verbs. So level 1 is we're using different URIs, but we're always using, say, the post verb. Level 2 is we start to use different verbs combined with resources. Level 3 is this thing called hypermedia. So let's run through that. Level 0, HTTP transport still, but one URI, one verb. XML, RPC, SOAP. Level 1, we start to distinguish out different URIs, same method or verb. Level 2, we start to get these definitions of different verbs that come in. Get, put, post, delete, patch, and they all have specific definitions. We know that put is idempotent, because I'm updating something. Idempotency means I can replay it, and I'm always going to get the same result. If I say set x to 2, it's 2. If I then say set x to 2, it's still 2. That's idempotent. If I say add 1 to x, it becomes 1. Add 1 to x, it becomes 2. Every time I run it, I get a different outcome. That's not idempotent. It's not replayable. So we get these types of definitions we understand. And we also get then specific response codes that we start to use in our API as well. So every time we make an HTTP call, we get some response code that comes out. So in this case, Google responded to me when I went to google.com with a 301, moved permanently. So they actually went and redirected me to a different path. They redirected me to google.com.au. Right? Now, there's lots of different status codes, more than you might typically have encountered. This is a website, httpstat.us, built by yours truly. And what this does is, first of all, it just lists out all these different status codes you've got. So for example, there's a specific status code there for a 201 is created. So if I post to customers, we don't just want to return a 200, we can return a 201, which comes back with metadata, has a location header of the customer we created, /customers/6, stuff like that. There's all kinds of other stuff in here of, particularly some of the redirects. Like there's actually 1, 2, 3, 4 different types, 5 different ways of redirecting. All those codes have slightly different semantic meanings that have different effects, whether the browser remembers them. So we start to respond to all these different codes. My favorite one is HTTP 418, which is when something returns, I'm a teapot. That is a valid HTTP response code that is defined with an official specification, which is RFC 2324, and it's the Hypertext Coffee Pot Control Protocol, and it defines methods like brew, the brew method. There's a get method for retrieving the coffee, and the when method to say when to stop pouring milk. These are all official HTTP methods. But if you accidentally send a brew method to something that's not a coffee pot, there's a 418 response code to say, I'm a teapot.
Excellent.
Totally exists. It was written as an April Fool's joke, but it did go through the entire standards track process and is released as a numbered standard. So it is equally valid as any other standard. It is actually, as much of a joke as it is actually reasonably useful in the sense of anywhere that people are writing HTTP APIs and things like that, as in the libraries that go and talk HTTP, it's a good little test case of making sure that it can support a 418, either sending or receiving a 418, to show you that it's truly sort of supports all of HTTP in the sense of any response code. So for example, if I, so the other thing this site does is if you go to like http://stat.us/418, it'll give you a 418 response back so you can test how your code reacts. So here Chrome is saying it got a 418 response. So, but technically I can actually use any 3-digit code. So I can have like an HTTP 943 that doesn't exist, but I can see that Chrome is handling a 943 and make sure that's passed all the way up the stack, right? So 418 is actually quite a nice, useful little test scenario for that. But I'm a teapot. Anyway, so we start to use response codes. 200 and 404 being the ones we know best. 201 created, 204 no content. I received your call, but I've got nothing to give back to you. Thanks very much, it worked. That's all it means. And then different unauthorized, forbidden, not found. Level 3 in an API, we start to get into this thing is what we call hypermedia. So this is where the API starts to define the API itself. Sounds a bit crazy. So here, I might execute a GET request, get account 12345. In this case, we've got some XML back. 200 OK, here's the account. The account number is 12345. The balance in Australian dollars is $200.54. Link, rel, relationship, deposit. If you want to do a deposit, here's the API endpoint. If you want to do a withdrawal, here's the API endpoint. Right, so we start to discover the API as we hit parts of the API. So then our application will say, okay, I've loaded the account. Now I'll take that withdrawal link and I'll bind it to this button when the user clicks the withdrawal button. Why is that useful? If the account's overdrawn, we just take the withdrawal endpoint away. Now, we're still going to have to protect against that on the server if somebody goes and hits it, but we can start to declare what operations are available on different objects as we go down. That's kind of the level 3. So level 1 POCs, sorry, level 0 POCs, 1 resources, 2 verbs, 3 is hypermedia. These things sound really wacky. You use one every day. It's called a web browser. The HTML in a web browser defines what it can hit next, and it says whether to use a GET or a POST or a PUT, right? RSS readers, same sort of thing. So in this way, rather than having, say, like a is overdrawn, so if we go back to this scenario, one way that we could build this is we could go and write code in our UI that says, if the balance is less than 0, hide the withdraw button. But then what happens when you've got another business rule of, oh, what if the account has an overdraft facility, right? Then you've got to start to compare against that. So maybe we'd add a property onto our response that says, is overdrawn. And then in our UI, we know about whether we're going to enable or disable the withdrawal based on that. But now we're still pushing a bunch of our business rules down into our UI of knowing that withdrawal is based on whether it's overdrawn or not, right? Which hasn't traditionally been too bad, but now we're starting to get into a multi-channel, multi-device world a lot more, right? So I have a mobile phone where I want to be able to access a mobile web app and a WinPhone app, and then I have my Windows 8 device, and I want to be able to, all these different devices, and an iOS app and an Android app. So instead of having those business rules get baked down into them, all we do is from the API, we declare what operations are available or not, and then you make the UI react to that. So in reality, a lot of people don't really make it to that hypermedia level. That's fairly purist. In sort of line of business type applications, you're probably not going to get that far. If you were explicitly building an API for, say, broad public consumption or something, you were building the Twitter API, might be something you'd want to think about. So level 1's about tackling complexity. We break a big service down, we split it up into multiple resources. Level 2 standardizes on verbs. Level 3 introduces discoverability. Level 2 is a really good place to target. What that means we can do at level 2 is, by standardizing on verbs, things like caching, for example. If we send cache headers on a GET request, the browser can cache that data. So instead of us in our application going and writing code that says, okay, only download the list of accounts that the user has every 5 minutes, store it in this dictionary, look it up from there, that sort of stuff. If we do a GET request for that, and that comes back from the API with cache headers on it that say 5 minutes, then the browser will cache that for us. So the next time in our code, we just ask for the accounts list, and the browser knows about the caching, can do that for us, right? Then, back on the server side, let's say we're starting to ramp up our servers, and we actually want to put like a proxy layer in between our servers. So the request comes in, goes to a load balancer or a proxy, and then goes out to a farm of web servers. That load balancer in the middle can actually do caching as well. So the request might still come from the device into the proxy, but it won't go all the way down to an actual web server that costs us like CPU time there. All those semantics then actually come out on the responses, rather than us having to write application code to do that. While we're at a protocol level, something else to think about. If I jumped into, let's go to a page here, this one. And in my default HTML, I'm just going to chuck a script block in the bottom. What's that complaining about? Yeah, whinge. If I did a get to http://google.com, so this is just going to go and trigger off a basic AJAX request, and I can subscribe to events and stuff. If I reload this page, not opening that properly. I need to say send. There we go. I'm getting an error here saying XML HTTP request cannot load google.com. No access control header is present on the requested resource. It's not allowed access. Now, if I was building something where I had, you know, like mysite.com, and we're building a single page application, we might have the API somewhere like api.mysite.com. Actually, this would be www. We're not allowed to go and call across those because they're different origins, different domains. Now, the origin is the combination of the protocol, the host name, and the port, not the path and everything that passed that, right? And that's a security thing. Because otherwise, I could jump in here and I could do a post to facebook.com/wallpost. So I'm on some other website, but in the background via JavaScript, it silently goes and does a post to this Facebook place. It's going to use my cookies in my browser context where I'm signed in because I've stayed signed in, and all of a sudden some arbitrary website's posting to my Facebook wall, right? Security problem. So by default, these things don't get exposed. Now that's more designed for websites, and we need to protect against that. Where we're consciously building an API, and we want that to be callable from lots of different locations, there's a thing called CORS that we can do. CORS is cross-origin resource sharing. So what happens is there's a pre-flight request that goes out first of all. So the browser, you'll struggle to catch this in the network window, but when I went to do that Google or Facebook call, Chrome's going to go out, or the browser is going to go out, and it's going to ask that server, hey, am I allowed to call this thing? So it's going to send an HTTP call with the options verb. It's called the CORS pre-flight. And then that might come back with different access control headers. So the headers that come back, access control allow origin. They can dictate specific origins and headers and things like that, right? Now, if we then defined those, that would allow us to go and allow the browser to call that. If you're building an API yourself and you want to host it on something like api.mysite.com, CORS is probably going to matter to you if you're about to call it from your own application. So what you'd probably need to do is in your web config is have like a system.webserver section here where you go and add those headers onto all your outbound responses so that the browser can call it. Or there's other ways to do it with web API and things like that. But if you get into this error message of access not allowed, CORS is going to be the culprit, CORS. What it does mean is that sometimes you can't say, for example, in a browser, just go and hit, say, the Flickr API or the Google Maps API necessarily or something like that. some cases where you might hit that and you want to be able to query that from the client, you might need to proxy stuff back via your server and then do it from the server side. That's different because that way you're not running in the user's kind of cookie and security context on their browser. From an Angular sense, there's also a bit that comes in here, which is that you need to tell it to actually go and use cross-domain, so you're going to have to update how you do your outbound calls as well. And the headers matter in cores as well. It doesn't just look at the origin. You're only allowed to send certain request headers. Now, Angular, this is fairly specific. If you Google it, you'll find you can copy-paste this block in. But Angular, by default, sends an x-requested with header, which most servers won't define as a valid cause request header. So that'll still trip you up. So you have to make sure you remove that from the list. There's actually a cool little bit of JavaScript there. If I go var abc equals 123, abc dot, I've got properties and stuff showing up on that. I can actually say delete abc. abc doesn't exist anymore. IntelliSense is being dodgy. ABC doesn't exist anymore in that context. You can actually delete variables in JavaScript, which is also the way that if you had like var abc foo is bar, the reason that we had to use the delete keyword in that there is I can't just sort of go foo equals null or something. Like I actually want foo to disappear as a key from the object. So what they're doing in here is deleting something from the dictionary or deleting a property from that common object. That's a funky little JavaScript keyword that most people wouldn't come across usually. So that's REST. Very quickly, using this in an Angular-specific fashion, what this also means we can do is that rather than going and writing lots of really sort of network-specific code about go and query out to this place and stuff like that, we can use some higher-level concepts. So what I'm going to do is go into my transaction service quickly, and in this module, I'm going to actually I dropped the Angular resource stuff, I think. Here we go. I'm going to take a dependency on another module called ngResource. Then, in my factory method, in my service here, instead of just having like a data method, a data property, what I'm going to do is say return. Sorry, no, we've already got the return. And I want to return a resource. So my module data services depends on another module called ngResource. Then when I'm creating my transaction service like class object, I have a dependency on this $resource helper. I'm going to say $resource transactions. That's the name of my resource, so that's going to go into the URI, so like /transactions basically. No properties, it's just an empty object. And then I'm going to use this funky little syntax they have, so I'm defining another object, see brace to brace, here to here. And I'm going to say there's a query method. The HTTP method is get, and we expect that to return an array of results. So I can just define that. That's all I'm going to write. Now, if I go over to my transaction list controller, let's deminify this. It's human readable again. Transaction service, I'm going to say transaction service dot query. Let's go over. Now this isn't going to work because I haven't built that API, but if I refresh this, app depends on, my default HTML. I've added a dependency on another Angular file which I need to include, which is called Angular resource. So this here has sent out a network request to transactions as a GET request. It's gone and done that for us. All right. Now, so from our controller here, I can just say transaction service.query, and the actual client-side code I'm having to write now, because I'm able to work with these common concepts of REST, is minimal. Because I just say, transactions is the resource on the server. Anytime we want to query that, you send a GET request, and you expect an array to come back. That's it. right? If I wanted to, like create a transaction, method would be post. And all we're doing is telling Angular these little bits of mapping, and then it can work out all the underlying HTTP concepts. Pretty easy. So actually, let's quick race just to finish up. If under my controllers, I add a Web API controller class, transactions controller. So this is back on the server side. This works by convention, return new array, return, new transaction. Let's create a class to do that. Delete all the methods we don't need. Transaction. This needs to have the date, time, date. There was a nullable double for credit, debit, and the memo. We can initialize this here. Date equals date time offset.utc now. Let's go back 3 days. Let's do a $50 debit, and I'll just do a memo of ATM, and we'll just copy a second transaction quickly. Let's call that $150. There we go. If I build that, and I get a /API/transactions, I've got my transactions data has come back as XML, because that's what Chrome was sending as the default accept headers, right? If I copy this URL, open a new Chrome tab, and I'm going to use a Chrome app that I've installed here, which is called Postman. It's kind of a cool little one. You can get it from the Chrome App Store. This is just a really nice way of sending different little requests. So I can paste in that address, headers, there we go. Say, I'm going to accept application/JSON, send, and there we go. I've now got Web API sending me some JSON formatted data back. It's a useful little client for testing that sort of stuff. So we know our API works. In our service, if I just set the resource to API/transactions, go back to our page. Now, that's not working on purpose. If I zoom this out a bit, go to network, reload it, we can see the request to API transactions in the list. I know it's small, but there's a get for /API transactions and a 200 OK. And if we look in the response, we can see a bunch of JSON. The thing that's happening here, though, is that our JSON that's come back, because we've just taken our .NET type and we've serialized it, we have Pascal cased. We've got capitals at the front. Now, we don't want to go into our C# and start writing lowercase in here. That would be ugly. We also don't want to start writing uppercase in our JavaScript. That would be ugly. So the last thing I'm going to do to make this work, if I jump into my global ASAX, I can put some extra config into Web API, where my application starts up. Global configuration dot formatters.JSON formatter dot serializer settings. Whoops. And I can say, I can actually even do formatting equals formatted.indented. Nice. And I can say type name handling equals new camel case. Where is it? They hide it. Newtonsoft, JSON. Oh no, sorry, not type name handling. Oh, now I'm going to forget where the property is. right? The way we really program. Web API, we go casing, JSON, camel. Contract resolver. So that's going to say for all web API responses on the way out, camel case them. So now I refresh this. There we go. I've got data loading. So that was like, I don't know, between 5 and 10 minutes, built a web API, returned some data. But the entire code that we had to write in our client to actually go and react to that is that. That's all of our network code is like 3 lines, right? Because it can work on the conventions of REST. It knows how to go and talk to it. Cool. So, what do we go through there? We went through a wraparound of intro to Angular again. We separated some stuff out into some nice modules. We did some dependency injection between those modules. So we separated our controller from the stuff that wrapped our actual data services of how to talk to stuff that was separate from the resource module. We wrote some unit tests using Jasmine that we were able to execute using Chutzpah. Which went and mocked out the data services so we could test just our controller piece. And we rendered all out on the page. And then we built a web API at the end of it on our server that returned some real data. And we went and camel cased that down. That's a fair amount of cool stuff in a very short period of time. Awesome. Thank you.
I've been running SSW for 20 years. I've also been a lecturer at the University of Technology, Sydney for many years, and I think the gap is getting wider between what they're being taught and what employers need for the guys to hit the ground running and be able to do real work.
Looking for a job as a junior developer can be really tough. There are so many applicants out there, and it's really hard for an employer to separate one from the other. They try really hard, but it's a challenge for them.
One of the problems when you come out of university is everything you learn at university isn't directly transferable into the enterprise.
I think I've seen all the problems that companies are having with new recruits. That's why we created Bootcamp.
The Bootcamp is a place where you'll go for 9 weeks, 40 to 60 hours a week, and do one thing and one thing only. That is learn to code in Microsoft technologies.
You're going to be learning MVC5, HTML5. These technologies are really important because the uptake in the industry is huge. So this course will just fill that gap between university and starting work.
At the bootcamp you have a mentor, and that mentor gets you over a challenge you may have straight away so you can go on to the next challenge. Instead of sitting there for hours searching Google and trying to find answers that sometimes you just can't find.
It's important to have a mentor because it stops you going off track. It stops you getting stuck on things that aren't really important. It happens time and time again where people are going through things that are found on the internet.
What they really need is experience and hands-on coding. And this boot camp is going to give people the hands-on experience in coding for 9 weeks. Because if you can do as opposed to learn, you have your best chance at getting job ready for your first job in the industry.
It's not an easy course. For 9 weeks, you're thrown into the fire. You live and breathe .NET code. You live and breathe learning best practices and working as part of the team. You'll be working a minimum of 40 hours and mostly 60 hours a week, every week.
Becoming job ready is more than just learning how to write code. You need to know how to work in a team, you need to know how to gather requirements, you need to know how to use the tool set, the Microsoft stack of tools. And during the boot camp, we're going to be teaching you all these other aspects, the soft skills of development that, by yourself, learning from a book, learning through Google or videos, you just will never learn.
It's not just coding skills, it's also communication skills and the ability to work as part of a small team.
The whole course is run using Scrum, so you'll learn Scrum inside out. At SSW, we've been using Scrum since literally day 1, so you'll learn from all our experiences, and you'll just be able to join a company at the end of the course, and you'll be able to fit straight in their team, so you'll be a big asset to any company that you join.
One of the most exciting parts for the students is the gala at the end of the 9 weeks.
The gala is where you showcase what you've done to a room of prospective employers. This is where the rubber meets the road.
At this gala, you're going to be able to present the work that you've created and what you've learned, not to your mum and dad, but to real employers, people looking for junior developers. And at that gala, you're going to be able to present and then talk and discuss with them. And we're going to help you try and get a job at the end, because we believe that the graduates of the bootcamp are the best graduates on the market.
And that is a damn lot better than sending your resume to recruiters who you can only hope will put your best foot forward.
By spending 9 weeks intensely in the bootcamp, learning nothing and doing nothing but .NET programming, and then creating a real app that you can show your prospective employer is impressive. It's impressive because it shows you're passionate, and it shows that you've gone through an incredibly difficult course that most people would never go through. And that's the type of person that we look for at SSW.